Hi, everyone. Thank you for giving me time to talk about this. Cohort Survival, as Marti said, this is another package that we've developed within the Darwin EU initiative. And the idea of this package is to help the user perform descriptive survival analysis. So this is basically a wrap-up around the package survival, which for anyone who's ever done survival analysis, it's a very well-known package. And it just makes it easier to work with OMOP data because of like data structure and everything when performing descriptive survival. So basically, it reports Kaplan-Meier curve, so it gives survival estimation probabilities. And then there's a couple extra functions that I probably can't cover today, but you can check the website where much more information is available. This is available on CRAN, so you can just install it like this. And for this very short demo, I'm gonna just talk about some basic functions, and I'm gonna use a data set called MGOS2, which is adapted from a mock data set from the survival package that we've OMOPed, and it's available within the Cohort Survival package as well. You can create a CDM like this. Marti has talked about the CDM, so I'm not gonna say anything about it. And this CDM object has three main cohorts. The first one is MGOS. So this is the people who are diagnosed with MGOS. These I'm going to treat as a target table. This also has some extra columns for age, sex, and other variables, which I'm going to use for stratification later on. And then there's two main outcomes in this CDM. First is progression to multiple myeloma, which I'm going to treat as the main outcome later, and then a death outcome, which is going to be the main outcome first, and then a competing outcome in a later example. This package has two main functions. So the first main function is estimate single event survival, which only needs a CDM object as an input, and then to define which are the target and the outcome cohorts. There's many other inputs that can be decided, things like restricting the minimum survival for the people in the target cohort or asking for a certain follow-up or things like that. But the only required inputs are these three. And then this function outputs all the survival estimation, like the probabilities, in a format that we call summarized result, which is a output format that we use across all the Darwin packages. And we have an inbuilt plot function. You can specify risk table and other things to plot these Kaplan-Meier curves. You can also plot the cumulative failure probability if you want. And then there's also this stable survival function, which extracts survival summary. So the survival estimates for the times of interest, restricted mean survival, or median survival. And it does that for all the outcomes that are required and or all the stratas if available. There's additional information that can be extracted from the output, such as the events, the people at risk, the attrition, and other things like that. But I'm not going to get into that today. As I said before, we can also stratify our results. So if you call the function with strata, you can get the survival estimation by stratification. The only requirement is that all these variables are columns in the target cohort. And therefore, then you can plot the results by strata. You can then get you can also get the risk table if you want below the plot, and then you can get all the summary for all the stratification. So that's one of the main functions of the package. The other one is estimate competing risk survival. This function basically allows the user to do competing risk. So sometimes you might want to do survival analysis, but apart from the main outcome of interest, there's another outcome that like competes with it. So in this case, we might be interested in like studying the progression to multiple myeloma, but then we might have also like death as a competing outcome. Obviously, people who die cannot progress, so we might want to take that into account. And then just, again, these are the only parameters that must be stated for this function to run. And then we can plot the probabilities for both outcomes of interest, and then we can retrieve the survival summary as well. And in the same way, we can also specify some stratification, and also plot for all the stratas and get all the summary. So that is really the main usages of these package, just like the descriptive survival. But sometimes the user might want to model. This package doesn't have inbuilt functions for modeling, but it makes it easier for the user to use other packages. So, for instance, if one wants to like do Cox pH, what you need is for your target cohort to have time and status variables. So we have an inbuilt function called add cohort survival, which basically adds those two variables to your target cohort, and then this cohort has the necessary structure to be the input of a typical call to a Cox pH function in the survival package. And similarly, for risk, for competing risk, there's these add competing risk cohort survival function in the package that adds these two variables as well. And these output has the format to call, for instance, a this CRR function from CMPRSK, which models to do fine and grained modeling if necessary. This is just some extra code because this function needs sex to be a binary variable. Well, this is another example. I don't think I have time to cover these. So as I said before, any questions or any more like information, you can reach out to me or you can check this website. And obviously this is a project of many people. So thank you for all the help.